In your math classes, you've undoubtedly learned about coordinate systems. We can think of coordinate systems kind of like your standard x and y graph, right? You'd count up in x along your x-axis, you'd count up in y along your y-axis, and by specifying both an x and a y, you can pinpoint any location on, a coordinate plane, as I guess we call it. Now, this applies with maps and finding locations on the Earth as well. There's an imaginary coordinate plane on our Earth. We call it latitude and longitude instead of x and y. And so any location on the Earth, say Michigan, has a very specific x and y location. 84.6 degrees west, 44.2 degrees north. That's like our x and our y. Now the origin of this system is different, right? Like our y-axis happens to just be defined as here going through Greenwich, England, and our x-axis is defined by the equator. Now, that makes sense when we see it kind of like this on an xy graph, but we can also translate this to looking at a spherical object, which the Earth really is, right? This x and y location, latitude and longitude, allows us to specify any location on the Earth, right? And so it's no different just because we're on this ball, shaped thing. It's really no different. It's still an x-axis and a y-axis. Two coordinates can give us any location. Now, when we're looking at the sky, we often think of the whole sky like a giant sphere around us, like a glass sphere. We call it the celestial sphere, in fact. And so we like locating something on the Earth, we can use two coordinates to find the location of any object in the sky. Now, there's different types of coordinates we use, and we're going to talk about two different kinds. The first one is the horizon coordinate system. And it uses two measurements. One is called altitude, and the other one is called azimuth. So let's just talk about what these things are. So here's this nice little simulation. There's a dude standing there, and we have the celestial sphere, this imaginary glass sphere all around us. That's where all the stars are located. And we want to be able to say, well, where is this star at, right? It's a cool, bright star. We want to point it out to somebody else. Well, we can do that with two coordinates. The first coordinate would measure up and down from the horizon. So this big green circle here represents our horizon, right? Where we can't, the sort of dividing line between the ground and the sky, right? And so as I measure up from that horizon, I can measure this angle in degrees, and kind of maybe like you'd expect, straight overhead is a point we call the zenith, and that would make an angle of 90 degrees. You can kind of see, I can imagine like a little triangle here, starting at the horizon to the observer to the zenith straight overhead. That's a 90-degree angle. Now as I go down, 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 right, that angle gets smaller and smaller and smaller to the point where I maybe would be at 45 degrees, would be about halfway up on the sky. So we can see that again, right? If I drew the angle between the horizon, the person, and the sky, it's about 45 degrees. Okay, so we can measure the altitude. That's how high up it is. But now, in order to specify the location, if all I did was tell you the altitude, it could be anywhere on this circle, this little gray circle. So I need to also specify the direction of that star. So this is how we do that. We specify the direction with this thing called azimuth. So here's the four cardinal points or directions: north, south, east, and west. And the way we count azimuth is we want to give a number to specify the direction. We don't just want to say, well, it's northeast. We want to give it a specific number. And the way we do that is we say that north is 0 degrees azimuth. And we count up the degrees all the way around a circle. So east would be 90 degrees. So again, it's like starting from north to the observer to east, that would be 90 degrees. Down to south would be 180 degrees. That's the big angle all the way around, a straight line. And then we got 270 degrees, and then all the way back up to 360. Okay, so if I were to find a location here that's maybe in the southwest, about halfway up, you can see that south is 180, so this is about 217 degrees azimuth and 42 degrees altitude. So with this way of measuring, I can specify any location in the sky with just these two numbers, altitude and azimuth. All right, that's the horizon coordinate system.